Hi, I'm Alan Ross. We're here at the RE Plus Conference and Exposition. We're talking to thought leaders about the future of the energy economy. So join us and enjoy. My next guest is Brian Patterson. He is the founder and current chairman of Emerge Alliance, which is an organization you're going to tell us about. I'm just learning about myself. But I want to go into, first of all, how did you get into this from where you were? Because you were in IoT, you were in information technology, right?
Yeah, I actually started with consumer electronics and automotive electronics, kind of followed electronics up, percolating up. I'm an older person, as may be appropriate to say these days. But eventually, essentially followed the electronics industry, which landed into the communications industry, and to what we now know as the internet and everything surrounding computers and such.
Wait, were you the father of the internet? Come on, Brian.
Well,
have I finally met the father of the internet?
I once met Al Gore.
Did you?
So
good.
I guess in part I must have been.
You must have been.
I think I inspired at least a little bit of that.
So you go from internet to where you are now.
So when you look at the internet, it's really changed the information world, from centralized production of information, newspapers and big insurance companies pushing out their bills and stuff, to what the world is today, where 80 or 90% of the information that flows in the internet is created on that little gadget you throw in your pocket.
Yeah.
So it's completely turned upside down. Now most of the information is created and used at the fringe of what we call the edge of the information world, and makes its way back up to the center.
Did you know that one of our sponsors of this is Grid Edge? IEEE Grid Edge.
Grid Edge, sure, yeah.
And so it's at the Grid Edge.
Grid Edge is appropriate because the action today is going to be at the Grid Edge more than at the central. Now, some people say the solution to all of our energy problems is central production of energy and use more transmission lines and such.
They're all over 100 and they're dying off.
Yeah, that's true. But in some part, that's correct. So I would say that part of building out a future energy is equivalent to the cloud in information. But the cloud information is sort of the bulk of information. The real information creation and use is at the edge.
Right.
In your home and mine, and in the buildings that we work in, and so on and so forth, factories. So today we're still like the old information system, where most of our power comes from central places that are using 100-year-old, as you suggested, 100-year-old. It was you that said that, because I don't want all you to yell at me. But it's using older technology, although they're starting to put in some of the new technology. But this whole renewable movement with solar and all that provides an opportunity. It's almost like a microgrid that goes into a home is like a personal computer. It's a personal power system now. So it gives the opportunity, similar to what we did with information, where the edge, or the person at the final user, is now a producer also of power and so on.
It's creating all kinds of potential problems down the road, because now we're creating a grid system that was designed as a power generation step down is now a step everywhere. It creates transients, it creates power quality, it creates opportunity. Tell me about Emerge. How did Emerge come about?
So I'm in Armstrong World Industries, a company that does building materials.
Right.
But we were seeing the future of buildings being more adaptive, and I use a term that everybody I think uses, is that we wanted to see an augmented reality, meaning that the building would help make your environment more productive, supportive, and so on and so forth.
In IEEE, we call it a smart building.
The smart building, exactly. But it's even more than smart. There's things you can do to improve people's health and all kinds of things. So anyway, Armstrong wanted to go down in that direction, and it was logical then you had to power these things, to do all that stuff, you have to put power. But to run the current way of running electricity with 110 volts or more of pretty strong, I'll call it, power lines and stuff, it's expensive and you can kill people, let me put it that way simply. So to really surround you with that would be a little bit hard to do, dangerous, and maybe not the best thing to go.
Wait, so that's what we've done. So now every time I go into a building, am I going to feel like, oh my gosh, this thing is going to kill me?
At the personal item stuff, your computer and all that, you notice that you have to go through the brick, and the
Right.
brick takes all of that nasty stuff and makes it wimpy, you know, and,
Right.
and so you're not going to kill yourself. So you can actually touch the end of that thing and you're not going to get a shock. We call it touch-safe electricity, right? So we can power the small things now with modern electronic technology, but more recently, in the last several years now, say half a decade, power electronics have gone from just doing small amount of power through a transistor to enormous amounts of power
Right.
using power electronic capability. For those who would be interested, the bigger technology would be insulated gate bipolar transistor technology. These transistors that can switch just as fast as a computer, or nearly as fast, but can handle enormous amounts of electrons going through that switch,
Yeah.
that semiconductor switch. And so that has given us the opportunity to apply everything we learned to digital articulation of information and bits and, you know, all that,
Right.
electrons, to apply that to the electricity world of motors and sensors and all the things that we do. As a matter of fact, most of the appliances in the home today, if you buy the most modern appliances, are all electronic inside, even though they're being fed this AC power, which is 100 years old.
Yeah.
And that's no discredit to the AC, but it's just not, you know, what the machine wants. It wants DC power, so what do? We have to convert it. That takes away some of the energy, makes it a little more expensive, makes it a
Yeah.
little more complicated and prone to failure and things like that. So we had the idea that, hey, what if we created this world that used the right kind of power, which would be DC power, direct current, and we power all that stuff with DC, and you wouldn't have to go through all the conversions. First thing is, everybody says, well, you pick up some efficiency, but is that enough really to
10%.
Yeah,
Yeah.
or maybe less in some cases,
yeah.
sometimes more depending upon what you're using. We said that's not enough of a thing to do, even though it's pretty decent. The conservationists love that, but most of the other people that are, as I call it, power pigs, want, you know,
isn't
5%'s not enough.
Isn't that just the Tesla world? Nikola Tesla, if we'd have done it his way instead of Edison's way, we would have been in a DC world?
No, it's the opposite. Actually, Tesla was a proponent of AC, and Edison ended up kicking Tesla out of his organization because Edison wanted the world to be a DC world. And Tesla helped perfect, although most people give him the credit for inventing, although he didn't, it was really invented over in Europe, is the AC motor
Yeah.
and the AC transformer. He perfected those things. What those devices were able to do is allow you to take the voltage that you produce at the level of a generator, step it up to a higher voltage so that it could run through power lines that were reasonable in size, and then you'd step it back down at the point of use to the device that's only 100 volts, let's say.
Yeah.
And the Edison light bulb was 100 volts. So you could run the Edison light bulb off 100 volts of DC or 100 volts of AC. But if you tried to transmit 100 volts of DC and had no way of stepping up the voltage to a higher level so that you could use smaller wire and all, you could only run it maybe a mile or two.
I love it when you talk dirty. You're talking about power, man.
Yeah, and at the time, generation was all done with internal combustion,
Yeah,
right?
yeah.
Or steam, which came off of internal combustion, or burning
Right.
something, right? So that was not a great proposition, you know. That means it's like a little power plant spewing whatever every mile or two in the middle of town, you know, and that wasn't going to fly. So AC and Tesla's perfection of the motor and the transformer, as we call it now, stepping up and stepping down voltages, allowed us to put those. Today they're not this, but back in the day, those stinky, noisy power plants, we could put them off away from the population,
Right.
and nobody minded too much.
Yeah.
Then you only had to worry about the big wires going overhead and all
And
that.
nobody minded too much until
Not
we found
until
out that
we
they give you cancer, right?
Yeah, right, until
Yeah,
we
yeah.
started realizing that that's probably not good stuff either.
But
There's
you
a-
still haven't gotten to emerge yet. I got to get to emerge
so,
yet.
so at Armstrong, we said we need to electrify the interior of a building. We need to distribute power into the walls, the ceilings, every place. So when you plug things in and move things around, you always have power at the ready, so to speak, without having to move wires and all that, which is very expensive. So we started thinking about that, and we said, well, that's really not just an Armstrong thing. That's going to have to be, everybody has to be involved in that, the whole building industry. So we said, sounds like what we have to do is form an alliance with a whole bunch of different people. Armstrong didn't make lights, for example, light fixtures or